Hello, my geometry students. It is day 4 of our transformations unit, which is all about rotations, which is exactly how it sounds, just rotating or spinning something. So we're going to talk about, or what are all the fine little details that you need to know to be able to rotate a point or an object correctly. Right? So a couple things. You need to have a center of rotation. So that's the first thing here. They're saying if you rotate about a point P, known as the center of rotation, each point and its image are the same distance from P. All the angles with vertex P formed by a point and its image are congruent. So that should hold the shape the same, all right? If you have a positive angle of rotation, we are going to rotate counterclockwise, which might seem counterintuitive, but it's following the quadrants. And then if you have a negative angle of rotation, that just changes the direction. In that case, that means that you would rotate clockwise. Right? So when it says, unless specified otherwise, the point you're rotating about is the center of the graph, which is the origin. So if it doesn't specify, we're always going about the point 0, 0. All right. With these first few, we got to plot the point first, and then we'll do the rotation. Oops, let's slide up here. Okay, so this first point, we have the point 5, 2. So go ahead and take a second. I just like to label, otherwise my eyes jump. So here's the point 5, 2. That's our point A. And we're going to rotate it 90 degrees about the origin. So the easiest way for me to do this is to actually rotate the paper. So we have to follow it since it's a positive 90 degrees. That's how I know how I'm turning it. Right? Means we're going to go in a counterclockwise manner. So I'm going to literally jump from quadrant 1 then over here to quadrant 2. So I'm going to turn my paper. And when I do that, when I do a quarter turn, it now looks like this. So how I read it is I now look at it like this is my x-axis and like that's my y. And I figure out what are the coordinates of the point here. So if I pretend this is x and this is y, this would now be the point -2 up 5. So -2, 5. So I'm going to turn my paper back and write that down. And I'm going to label that as the point A prime. So I'm going to say that's my answer. That's my image here. So let's go ahead and plot that. If we now go over and plot -2 and then up 1, 2, 3, 4, 5, I'm saying that that's where the point lands. Where you can see the 90 degrees is what I now want you to do, is just use your pen or pencil, and I want you to connect A to the origin here. And I want you to connect A prime to the origin. And what you should see is that nice 90-degree angle right there. Right? So that's how you know you've rotated at 90 about the origin, which was the center of our rotation. So let's do the same thing for the next one. Plot the point first. So you have the point 3, -4. So we're starting right here. So we're calling that point B. So the way we read this, that capital R means rotate. 180, that's our number of degrees that we're going to rotate. So we want to rotate 180 degrees about the origin. And because it's positive 180, we're going counterclockwise again. So 90 would land us in this quadrant. I'm going to go one more. I'm going to land all the way over here. So it's going to go from quadrant 4 past quadrant 1, and it's going to land here in quadrant 2. All right, so that means I'm going to take my paper. Here is a 90-degree turn. Here is a 180. So when we do a full 180, sometimes you hear that terminology. We're turning completely around the opposite direction. So now what that point looks like is the point -3 up 4. So when you turn your paper back around, let's write down -3, 4. And let's label that as B prime, and then go ahead and plot it on your graph. So -1, 2, 3 up 1, 2, 3, 4. That's where B prime should be. And now if you connect B, to the origin and B prime to the origin, what you should notice is that they're all collinear. They're forming one straight line. And that right there is a straight angle, all right? So here was a 90-degree turn. Here is a 180 degree turn because we get that nice straight angle going on there. Let's try C. When we come down here, this time we're using the point -6, 1. So -2, 4, 6, 1. That's point C. All right, we're going to rotate it positive 270 degrees. All right, so again, think about where you're starting. We're in quadrant 2. So I can label the quadrants. This is not something you typically have to do, but it might help for this scenario. So 90 degrees would land you here. Another 90 would land you over in quadrant 4. One more 90 will land you all the way back up in quadrant 3. Right? So I'm going to turn my paper so I can turn it so that my point, oops, sorry, I had to think there. Now it looks like there's 90 degrees, another quarter turn. There's 180 degrees, one more. I'm at 270. Now, unfortunately, on a video, I'm not trying to make you dizzy, I promise. But where the point should sort of look like it is now, I'm going to cover up my labels. It should look like it's up in quadrant 1, which is what we said. So if I look at this as being my X and this as being my Y, this would now be the point 1, 6. Okay, hold on to that thought. Fix your paper. Write it down. This is now the point 1, 6, and we're going to label it as C prime. So go on your paper, go over to 1 and up 1, 2, 3, 4, 5, 6. There's C prime. Right? And now what I want you to do is I want you again connect C to the origin and then connect C prime to the origin. And now what it might look like is it might look like a 90-degree angle, and you wouldn't be wrong, except for the fact that it didn't go from here to here. It went from here all the way around to there. So when I see this, this is a 270-degree turn right there. Now, because it does look an awful lot like 90, is it the same as if we had done 90 just going the opposite direction? Yeah. So that's our last one. If we do a rotation of -90 degrees, it's not that it turns into itself. It's the fact that now here, we're going to go clockwise. So go ahead and plot the point. So we have 7, 6, 7, -1, 2, 3, 4. So there's point D. And now we're going to rotate. And instead of going counterclockwise, we're going to go clockwise. So this point should land over in quadrant 3 when we're done with it. Right? So you have to turn your paper following the arrow. So it's a 1/4 turn in the direction of my arrow, so in a clockwise direction. And now take a look at the coordinates of point D. If I now look at this as if this is X and that's Y, this would now be the point -1, 2, 3, 4, -7. So -4, -7. Turn your paper back, write it down, and that would be point D prime. So -1, 2, 3, 4, and then -1, 2, 3, 4, 5, 6, 7. Ooh, our arrow is almost dead on right there. So there's our D prime. And then lastly, go ahead and connect the point. Now, in the future, do you have to connect to the origin? No, that's just to kind of visually confirm that our rotation is correct. So here we can see that 90 degrees right there to go from D to D prime. So sometimes you might be asked for an actual coordinate point. Sometimes I might just say, hey, if a point's in quadrant 1 and we rotate it -90 degrees, tell me what quadrant it should land in. Based on which direction we're going, clockwise or counterclockwise, you should be able to answer that. Right? Don't be surprised if your post-video question might have something to do with that. So moving on to the next page here. On the next page, I graphed mine already. If you want to pause the video to graph yours, go ahead. Otherwise, it starts you with triangle ABC and says, all right, let's draw the image A prime, B prime, C prime after a rotation of 90 degrees counterclockwise. Whoops, there's more about the origin. So all of that is important. So if we're going to go counterclockwise about the origin and then state the coordinates, here's where you have a choice. I am visual. I like turning the paper, but could you write yourself a rule? Sure. So let's go back for 1 second to take a look at what happened back here. When we're rotating 90 degrees counterclockwise about the origin, that was this first case right here. So if we look, that point, let me grab a different pen here, was x, y. If you look what happened, the y value came up front and got negated. So it went negative y. The x value stayed the same. It just went to the second half of the parentheses. So if you're someone that works well with a rule, we can use that rule to help us. So I'm going to write that rule down on the next problem, that for all of these, the point x, y is going to go to the point negative y, x. Now, I'll always show you the rules, but I don't tend to refer to them a lot because I honestly don't have them memorized and I don't use the rules, but that's how I work. If that's not how you work, you have to do what works best for you, all right? So let me show you a little bit of both. If I start with A, which is negative 3, 2, B, we've got negative 7, 3, and then C is negative 6, 5. If I take A and I say, okay, let's rotate it counterclockwise, so we're going down this direction. For me, all I would do is turn my paper again so that you can see it one more time. I would turn my paper a quarter turn and now look at point A and say, all right, if this is my X and that's my Y, this is now the point negative 2, negative 3. So that would be my A prime. Now, does it match the rule that we wrote? Well, let's look. X goes to the back. So negative 3 went to the back and stayed negative 3. Y comes up front and gets negated. So the 2 came up front and got negated. There you go. It follows the rule. So I'm going to go to my graph, plot negative 2, negative 3. You can connect it to the origin if you want to be able to see that 90-degree angle pop up. Otherwise, you don't have to. So let's try this next one just using the rule. So for B prime, take the X, put it in the back half. So negative 7 goes to the back half. 3, the Y comes up front and switches signs. So this should be the point negative 3 and then negative 7. So 1, 2, 3, 4, 5, 6, 7. All right, there's our B prime. For C prime, totally up to you. All right. I like that you could still rely on the visual. So you can turn the paper and that's now the point. You know, negative, what is that? 5, negative 6. But it is good to have a rule sometimes to be able to double check and make sure that it works. So negative 6 went to the back, 5 came to the front but got negated, right? And plot that point. So 1, 2, 3, 4, 5, 6. I feel like I did that wrong. 1, 2. Well, I guess they are that close together. All right. Go ahead and connect the dots. And then if you want, could you connect one of the points to its image? So like point A to its image A prime and see that nice 90-degree angle pop out? Absolutely. All right. So keep confirming, keep reaffirming what you hopefully already know there. All right. This next one, let's see, is 270 degrees about the origin. Whew. So when we look at this one, again, you can take each point and you have a choice. A rotation of 270 degrees counterclockwise about the origin. This is the same as 90 degrees clockwise about the origin. So you could turn your paper clockwise and come this way and write those points down. Or we can go back and see if we can create a rule. So when we come back here, let's take a look. We just acknowledged that these last two are the same. So we should be able to build a rule kind of off of either one of them. So negative 6, 1 goes to 1, 6. So what it looks like, the X coordinate goes to the back and gets negated. And then the Y coordinate 1 just came up front, stayed the same. So it looks like it goes to Y negative X. Let's test that out over here. So if I have X, Y, the X of 7 comes to the back and gets negated. The Y, negative 4, jumps up front, stays the same. So there we go. That confirms it. All right, let's write it down back here. So that means the point X, Y goes to Y negative X, like that. So if you'd like to use the rule, you've got it. All right. So the visual or the rule, either one will get the job done here. Right? So D, we've got 5, 3. E, we've got -7, 6. F, we've got 0, -8. All right. Something to keep in mind, because we're rotating about the origin, it's like we literally picking this triangle up and rotating it about. It's going to overlap with itself. That's okay, right? Whereas in the last one, because it didn't overlap, you can kind of see it circling about the origin. So you should have kind of that like little preconceived expectation of what's going to happen here, right? So let's try using the rule since last time we started with rotating. So 5, 3, that's my XY. Based on the rule, 5 goes to the back and gets negated. And then the Y comes up front, stays the same. So if I go over to 1, 2, 3, and then down 1, 2, 3, 4, 5. Sorry, you guys can probably hear my dog Teddy. There's probably somebody like walking by. He's barking away. All right. Let's do the same thing with E prime here. All right. X goes to the back and gets negated, so it's +7. Y comes up front, stays the same. So 6, 7. So 1, 2, 3, 4, 5, 6, 7. There's E prime. All right. F prime, for the sake of the practice, right? We said it's the same as a 90 degrees clockwise rotation. So you could counterclockwise spin your paper 3/4 turns, or you could simply say, okay, clockwise, let's go 1 turn this way, and let's look at point F. So point F now, if this is my x-axis and that's my y, would be at the point -8, 0. So that's where, oops, bring it back here. It should be. So you just make sure that both are making sense. The reason I like the turning of the paper is by the time we finish rotations, dilations, transformation, or translations, and reflections, there's a lot of rules to know. So to try to commit all of them to memory can sometimes be a little overwhelming, and you can mix them up. But you can always go back to kind of looking at it and saying, does this make sense? Does it fit based on what I'm expecting to see here? All right, last part. Is a rotation a rigid motion or an isometry? If you remember, an isometry means the shape and size stay the same. Well, absolutely. The shape and size did not change at all. So yes, okay. The size and shape of the triangle stays the same. Yay. There we go. All right. We're going to hop around a little bit. On the next page, when we flip on over, number 3, we're going to wait to do that one together in class. So I have it graphed and ready. If you guys want to get it graphed and ready, go ahead. Otherwise, we're going to move right on to number 4, because number 4 is a little bit different. And I like this question, but it's worth looking at together because it is a bit different. Okay. So it says the vertices of triangle PAL, P-A-L here, are given when we go to do the image of PAL, which is going to be a rotation, 90 degrees counterclockwise, but about point P this time. So that's what's different, is about point P, which means now we don't have a rule to use, right? So there's no rule to rely on. We have to rely on the diagram. It says state the coordinates of the image. So a couple things. Let's just write the points down first. So we have 3, 2. A is 7, 2. L is 3, 4. Okay. So now P is going to become the center of rotation. So this guy right here. Mm-hmm. What I essentially want you to do is I want you to treat point P like it's the origin. So what I'm actually going to do is I'm going to kind of draw over this in my red pen because I have it sitting next to me, almost like a new little set of axes. So I'm going to treat that horizontal that goes through P, which is the line y equals 2, and the vertical that goes through P, which is the line x equals 3, as a new set of axes here. So I'm going to kind of retrain my brain. All right, if we now go and rotate counterclockwise, so it's everything's rotating this direction. The easiest one on here is point P, because if you rotate about the point itself, it can't go anywhere. That's invariant. So that's going to stay at 3, 2. Right. Some good vocab terms right there. All right, the point 7, 2. Well, let's take a look. If we rotate this point 90 degrees, you have a nice 90-degree angle right here. this should come on up here somewhere. So how far? Well, let's look. If I look at this and pretend it's the x-axis, this would be the point 1, 2, 3, 4, 0. So when it rotates up, that should now land 4 units above. So 1, 2, 3, 4. Here is where my A prime should land. And so what are the coordinates of that point? Well, that's where I have to remember that my little red axes are not the real ones. This is the real one. So now I'd have to come back here and think, okay, from here, I'm going over 3 and then up 1, 2, 3, 4, 5, 6. So that's my new coordinate point. 7, 2 to 3, 6 does not exactly fit any, special rule. So we can't really generalize it the way we had before. All right, let's see if we can do it again. Take point L, and now you're rotating it 90 degrees. So right now, it's on that vertical. I'm going to rotate it down so that I have that nice 90-degree angle there. If it's 2 units above point P, when I rotate it, it should now be 2 units to the left of point P. So that's where L prime is going to land. What are the actual coordinates of L prime? Well, go back to the real axes here. It lands over 1 and then up 2. And so that's my coordinate point there. If I finish the diagram, it sort of blends, unfortunately, with my axes, so maybe I'll highlight it a little bit. So I have triangle L prime, A prime, and then actually I can label that P prime as well. Here's my triangle right here. I'll highlight the whole guy in there. Why not? So I like that one. You have to really focus on the visual in that case to make it work. All right, let's see. Are there any last ones? Oh, just the rules. So let's quick summarize it up so that we have this to be able to use, and then we'll call it quits for today. So back here, the rule for reflection, or excuse me, rotation of 90 degrees, all of these ones, the assumption is that we're rotating about the origin, right? So rotating 90 degrees, this is negative y, x. If we're rotating 270 degrees, this is y, negative x. Rotating 180, we jumped that example, but we can still write the rule down. If you look back on the very first page, the x and y coordinates just both end up getting negated. So it's negative x, negative y. And then the review. These are all the rules we've learned so far. So when we reflect over the x-axis, the x stays the same. The y is what gets negated. When you reflect over the y-axis, the y stays the same. It's the x that gets negated. When you reflect over the origin, both the x and y get negated. When you reflect over the line y equals x, here's where they switch spots. It's y comma x like that. And then the last one, if you're translating, this is where we simply are adding values. So we end up with x plus a and then y plus b. So there's a nice place to come to that has all the rules in one spot if you need it. Don't forget to answer the post video question and have an awesome rest of your day, guys.